Hello, good morning everybody. My name is Vishwadeep and I welcome you all on Unacademy Computer Science Channel for unlimited learning. In today's lecture, which is very important for you. Why? Just because I am going to discuss binary tree and its basics. So what exactly I have brought for you in this binary tree basics are about basic things, that what is the binary tree, what are the trees, what is the left child, right child, left subtree, right subtree, what is the height in the binary tree, and there are so many small things which we are going to learn, and this is very fundamental knowledge you are going to gain from this particular topic. Once you will understand today's lecture, then rest of the binary tree will be very easy for you, and definitely you will be able to score more marks from this binary tree if you will be able to understand today's lecture. Very fundamental, very core topics we are going to discuss about binary tree. So without missing anything, we will have a really great session with you. Let's get started. So before I'll go and start, let me introduce myself. I have written the gate multiple times. My name is Vishwadeep and this is my final year rank 19. In third year also I scored 682 all India rank. In the third year 682, final year this, after that 119, 440, and there are few more ranks I am having. Went for my masters to IIC Bangalore, another masters from BITS Pilani in data science, a rich experience of teaching overall, and these are the courses I am taking on Unacademy's platform. You wanna learn from Unacademy's platform, you can do one thing. Go to unacademy.com or download Unacademy Learner app, which should be a must-have app in your mobile phone for you guys now, just because you are learners, and on Unacademy platform we provide lots of free content for your learning. So go to Unacademy platform, search my name and follow my profile over there. What you will get is so many special classes. Those special classes are free. If those special classes you want in more organized way, then go to this URL. This is one of the web page I have organized so that you can get all the class links in more organized way. All the question sessions, all the theoretical sessions, all the previous year gate questions and everything I have organized over there. If you want to learn through the questions, then another option you have is enrolling for this test series, which is free. Go and learn from that particular test series, just because we are providing quality test questions in that particular test series. It is for free. You can enroll and learn from it. But still, if you are lacking somewhere, if you want that, no sir, we are having preparation, but still we are not able to solve the question, still our preparation is not well enough, then one option left with you is Unacademy Plus. Go for Unacademy Plus subscription. There we will provide live classes. Those are very interactive, so that anytime you face any kind of query question during the classroom training, you will learn a lot. So many students are asking so many doubts. Through those doubts also you will be able to understand each and every topic till the core. Yesterday I have conducted a full length test of 20 marks on the Unacademy Plus, just because my one of the course got completed, and that particular course, if you have heard about its testimonial or its feedback, its review, you can understand that how what type of question in the test and the quiz and in the practice we are providing over there, so that the students will have the highest level of understanding. So if you want to go for Unacademy Plus subscription, you need to use a code VDEEP10 for your subscription. What this particular code will give you, it will give you a it will be giving you a discount, plus it will give you a particular strengthening of my mentorship. Yes, my mentorship you will be getting, plus you will be getting a team ka support. Which team? There is a team which I lead, and that particular team is covering entire courses of GATE Computer Science. So we are having a team, we are a team, that particular team, this particular team support you will be getting if you will be using the code VDEEP10. If you are the person who needs a personal coach from Unacademy side, then that personal coach facility also we provide from Unacademy side in the Iconic subscription. This Iconic subscription is having all the facility of Unacademy Plus subscription. Apart from that, you will be having some study planner created by the coach personalized for you. You will be having study booster, personalized test analysis, and you will be having study material practice sets provided to you especially for your practice, so that you will be getting more and more and more and more efficient. So this is the time when we will start. This is the time we are going to start now. Now, if you are ready, then you just type down in the comment box you are ready, and then we will learn a lot. Yes, we will learn a lot today, and what I am going to explain you is very basic but very interesting topic, which is binary tree. So if you are ready, type down in the comment box, and then we will start the chapter. So yesterday I have talked about basic things of the tree. What is a tree, what is the node, edge, root, leaf, internal node, external nodes, and what are the levels, depth and height, and based on that we have solved some questions. Parenthesis representation of tree we have seen already. Now let's see what is a binary tree. Binary tree is a tree in which each node can have maximum 2 children means minimum 0. So एक छोटा सा एक ट्री जिसमें हर एक नोड के लिए कंस्ट्रेंट है. What is the constraint? That every node can have maximum 2 children. It can have 0 child, it can have 1 child, it can have 2 children, but it cannot have more than 2. Now I want your acknowledgement. Is this a binary tree? Single node, no any child. Is this a binary tree? Yes, it's a binary tree. Just because maximum children 2, yes. Minimum 0, fine. Is this a binary tree? Yes, sir. Is this a binary tree? Yes, sir. Is this a binary tree? Tell me. Yes. Is this a binary tree? No. Why? Just because a node is having more than 2 children. Very basic thing. Yes, very basic thing. Now, if you are having a binary tree, then this is not only the restriction. This is not only the restriction that every node has maximum 2 children. One more restriction is there. If we have any node with child, then we need to explicitly specify that the child is in which side, left or right. जी हाँ, आपको अलग से ये बताना पड़ेगा कि the child is left child or right child. That's why the restrictions become more. Means if I am saying that basically this is an example of binary tree, yes, but this is not fulfilling my binary tree ka restriction, and that is what the tree should have either left child or right child if it is having single child. So this particular node, whichever this should be either in the left, counted as left, or right. It cannot be counted as the regular child. So that is one more restriction which you need to understand. Let's say this is the tree. In this particular tree, if I am saying ki root is A, can you tell me left child of A is what? Yes, A is having 2 children. Left is B, right is D. You can see here, left is B, right is D. Specifically bifurcated. अलग से बना के बताया हुआ है कि left में B है, right में D है. Right? Got it. If you are fine with this, now look at this. B is having 1 child only, left child only, right child is not available. Similarly, D is having 2 children, left is E, right is F. तो ये आपको अच्छे से क्लेरिफाई करना पड़ेगा. You need to clarify this clearly, explicitly, which node is in which side of the node, which child it is, left or right. You need to specify explicitly. Got it? Now one more thing comes apart from the left and right child. So I can say B is left child of A. आप बोलोगे सर ये तो पता था हमें, बट ये रिस्ट्रिक्शन होना ही होना चाहिए, ये आपको याद रखना जरूरी है. यू नीड टू रिमेंबर दैट रिस्ट्रिक्शन ऑलवेज. दीज आर द वेरी वेरी स्मॉल थिंग्स, बट व्हेन वी don't get those small things, then might possible we may face some difficulty in problem solving. D is the right child of A, yes, but there can be subtrees also. कल मैंने subtree के बारे में बात की थी. There was a talk about subtree. Can you tell me, is there any left subtree of A? Yes, there is a left subtree of A this much. So left child is B. B से start होके from starting from B as root we have a subtree. Yes, we have a subtree which is this one, and this particular subtree I can say it's a left subtree of A. Is that clear? क्या लिख सकते हैं ऐसा क्या हम? Can we write like that way? Left subtree of A? Yes. And do we have right subtree of A? Yes. This right child of A is D. Starting from D as root, if we have a subtree, that is called as right subtree of A. Right subtree of A. So do you understand the only left child right child is what, and left subtree right subtree is what? If you talk about right child of A, right child of A means single node D. बस D के बारे में बात करेंगे. But if you talk about right subtree means starting from D as root, entire tree till the downside level, maximum level जहां तक है वहां तक का पूरा tree starting from D as root will be called as right subtree of A. Good, understood? Welcome everybody, welcome. If you haven't liked the session, please like the session को like कर दो यार. और सीखते हैं next चीज which is linked representation of binary tree. Okay, so the binary tree can be represented in the linked type representation. So what we will keep or what we will store in the binary tree as, we will store binary tree as a node in the form of nodes. So one particular node will have three fields. One is the data value, which you call as value or data or key or whatever. Then one pointer, that pointer will hold the address of the left child, and another pointer which will hold the address of right child. If I want to create the structure of such kind of node, how to write that? So I am writing structure of a binary tree node. So I am writing it as BT node. And in the structure we are having three fields. What are the three fields? First field is, let's say, character type of key. And then second field is a pointer. Now this particular left child pointer will hold the address of what? Another node. And what is the type of node? Same BT node. So I will be having a pointer of type same struct BT node type, and that name of the pointer is left child. समझ पा रहे हो? What should I write next? Next is a right child pointer, and right child pointer will have like this: struct BT node star right child. So it's a BT type, node type, structure pointer, right child pointer. That's how you can write the structure. And all these type of structures in which the member of structure is a pointer of self type. I told you what these structures are called as. These structures are called as self referential. Self-referential structure, to referring to the self type pointers. That's why. Okay, here, nice, amazing. Now, if this particular tree is given, how do you reach kind of tree in the linked representation? So first of all, you will be having a pointer, tree pointer. That tree pointer will be root node. Now on the root node, we have key value A. Find key value A. Now from A, we have two pointers, left, right. Now left pointer points to a node which keeps data value what? B. So data value of left child is B, and data value at right child of A is D. Now from B we have left child, yes, which is having the value C, And from the right child, is there any right child of B? No. So what should I keep here? Null. So for null, I will put a cross. For D, we have left and right. Yes, we have D say left and right. Left child of D is E, and right child of D is having key value F. Now, C is having any child? No. So left may null, right child also null. Similarly, E is having left and right child? No, both are null. F is having no any child? No, left and right both are null. This way, you can represent a binary tree into linked representation. Now, I want to ask you, can't we represent a general tree in these linked representation? A general tree, cannot we represent a general tree into linked representation? Now, see, is there any restriction of number of children in the general tree? A node can have 0 child, possible. 1 child, possible. 2 child, possible. 3 child, possible. 4, yes. 5, yes. 6, yes. 10, yes. 15, yes. 30, yes. 100, yes. So the thing is कि in the general tree we don't have any restriction that a node can have maximum how many children. If we don't know that a node can have maximum how many children, then how you will create a node structure like this? क्या आप बना सकते हैं? नहीं बना सकते. That is why such kind of node structure and such kind of linked representation for the जनरल ट्री. बट कैन वी हैव द सेम फॉर बाइनरी ट्री? यस वी हैड, मैंने लिया ही तो है बाइनरी ट्री में, यू कैन डू इट. बट द थिंग इज इन बाइनरी ट्री वी हैव अ रिस्ट्रिक्शन. What is the restriction in binary tree? कि we have for every node maximum 2 children. So because of that, when I have created a node structure, it was having what? It was having only 2 pointers, one for left, one for right. That's it. So you can not represent directly a general tree into linked representation just because there is no any restriction of number of children. But later on we will see कि there is a way to convert a general tree into binary tree. That later on we will see that general tree into binary tree so that you can store it in the linked representation. We will talk about that. Now look at this. If you understood this linked representation, now I am telling you how you detect a leaf node. Okay, let me take a simple example. Suppose this is the tree you are having. This tree you are having, okay, and represented in linked representation. Okay, represented in what? Represented in linked representation. Entire chapter will be having this linked representation basis only for the binary tree. हम binary tree में सारे के सारे जो एग्जाम्पल्स लेंगे वो इसी के बेसिस पे लेंगे. इफ अनदर रिप्रेजेंटेशन विल बी यूज्ड, आई विल टेल यू. सो रिप्रेजेंटेड इन द linked representation, I have given you a pointer. A pointer named T. I have given you a pointer named T. That pointer is pointing to this node. Means pointer is holding address of this node, value F. Now I want to check if pointer is pointing a node and that node is leaf node or not. How can I check? The node is leaf node? It is not having any child. Can you write the condition? Yes, you can write the condition. Oh, somebody written the condition also. If T is pointing a node and if that particular node is leaf node, I'll have to check if T, which is pointing to a node, its left child pointer is equal to null. If then the left child pointer and its right child pointer also equal to null. If that is the case, then I can say that T is pointing to a node which is leaf node. So I can say T points to a leaf node. क्या इतना समझ में आ गया है आप लोगों को? ये बहुत छोटी छोटी चीजें हैं, वेरी वेरी स्मॉल थिंग्स विच यू कैन डिटेक्ट डायरेक्टली, बट आई एम गिविंग यू सो दैट यू कैन रिमेंबर इजीली. फाइन, क्लियर? कैन वी गो फर्दर? कैन वी गो फर्दर? आगे जा सकते हैं, आगे जा सकते हैं. आई एम लॉट, यू ऑल्सो शुड लर्न अ लॉट. Okay, so there is a question. There is a question given. This particular question is very different than the regular nested or regular representation. Regular linked representation से थोड़ा different है. I will solve this question for you. If you can solve, well and good. Otherwise, I will explain and I will solve. Consider following nested representation of binary tree like this: X, Y, Z. It indicates Y and Z are left and right subtrees. Okay, not the child, not the child. Left and right subtrees. Y, this one and this one are left and right subtrees of X. So first thing, within the bracket, if three things are written, first thing is root, second thing is left subtree, third thing is right subtree. समझ में आया? समझ में आया? समझ में आया? Okay, yes, 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 great, great, great. Now look at this. What is given further? Note that Y and Z may be null, okay, or further nested. Yes, we know that the left and right subtree may be further nested, or you cannot have any left and right subtree, means you can have null over there. Which of the following represents a valid binary tree? Okay, fine. एक valid binary tree कैसे represent हो सकती है? Let's say option A. Let's check it out. Option A. Option A says that from the left to right, the very first quantity is root. Okay, fine. Second quantity 2, which is the left subtree, single one. And third quantity is right subtree. So right subtree में आ जाएगा आपके पास 4, 5, 6, 7. This is the right subtree of 1. Got it? Three quantities. First thing is root, second thing is left subtree, single node 2, right subtree is this, all nodes. Now let's expand this one also. Let's expand this one also. If you are expanding 4, 5, 6, 7, first thing is root. Okay, first thing is root 4. ये रहा first thing. Second thing 5, left child. Third thing 6, right child. अब ये क्यों दे रखा है? Why this 7 is given? 7 is given. Fourth thing means kind of this one, means this is not a binary tree. No, not a binary tree. Option A gone wrong. Option A gone wrong, not valid. Of course not valid. Now let's go for option B. What option B says? That it's very tricky. Option B, entire quantity in the parenthesis, first thing is root. Okay, first thing is root. Fine. Now second thing is completely this parent, and third thing is 7. So 7 is right child, of course, and the remaining things 2, 3, 4 in the single bracket, remaining is 5, 6. Like this it is. This is the left child. This is the left subtree of 1. Okay, now let's expand the left subtree. Let's expand the left subtree. Expanding left subtree means look at this, look at this, look at this. What I told, first quantity is root, second is left subtree, third is right subtree. What is the first quantity? This one. This is root, and its left child is 5, right child is 6, means I should have 2, 3, 4 as some kind of root, and its left subtree is 5 and right subtree is 6. No, that's not correct. That is not correct. A subtree cannot be root. A subtree cannot be root. Okay, let me expand this 2, 3, 4 also for you. Let me expand you 2, 3, 4 also for you. 2, 3, 4 के लिए 2 is root, left में 3, right में 4, and this particular 2, 3, 4 becomes root for left child 5 and right child 6. Na baba na. This is not a correct representation. A root cannot be a subtree. A node can be root, yes. Subtree cannot be root for 5 as left subtree and 6 as right subtree. No, not possible. So it's a wrong representation. Now let's go for C option. Let's go for option C. Option C, entire quantity. Okay, let me just clear this extra things from here. Okay, so first quantity is 1, root, fine. Second quantity is a subtree 2, 3, 4 in the left. and third quantity is a subtree 5, 6, 7 as right. Now let's expand 2, 3, 4. If 2 is the first quantity, 2 should be root. Second quantity 3 left, fourth 4 is right. Similarly 5, 6, 7, 5, 6, 7 first quantity should be root, second is left child, third is right child. ऐसे बन जाएगा tree. Good. So this particular option looks correct. Fine. This option looks correct. तुम कहाँ चल दिए? This particular option looks correct, but we will check for option D also. Surely we will check option D also. It says first quantity, first one is root. Second quantity 2, 3 null in the left. So 2, 3 and null in the left. And in the right we have 4, 5. That is the given thing. Let's expand this 2, 3 null. Let's expand this 2, 3 null. So 2, 3 null you can write as 2 first quantity root. Next quantity left, next quantity right, which is null. Fine. Now next here this quantity, first quantity 4 as root, next quantity given 5 as left. अब right का क्या करें? अब right का क्या करें? What is right? Is it null or is it anything else? It's not null, not given. See, look at this. Right child of 2 was null. That is why they have explicitly written null. Explicitly written null. So if they have explicitly written null, then they should write right child of 4 also as null. If they have not written, then there is some kind of ambiguity. There is some kind of ambiguity. If there is some kind of ambiguity, then you can discard this option D. You can go for option C as more appropriate correct answer. Everybody clear about this? Everybody clear about this? Can we go for the next thing? Yes or no? Can you clarify so that I will go and I will explain next thing? Another question is this. Very simple question it is. Can you draw a tree with 4 number of leaf nodes, binary tree, and let me know that how many nodes we have with 2 children? Yes, yes, yes. Good, 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 good. Okay, next, a binary tree T has 4 leaves. 4 leaf nodes are there in a binary tree. How many number of nodes we have with 2 children? How many number of nodes we can have with 2 children? So, if binary tree we get of 4 number of leaf nodes, let's draw a binary tree of 4 number of leaf nodes. These are the 4 number of leaf nodes. 1, 2, 3 and 4. How many nodes we have with 2 children? 1, 2 and 3. My answer is 3. Easy question. Easy question. A binary tree, 4 number of leaf nodes. How many number of nodes with 2 children? Answer is 3. I have drawn the tree. In fact, this is not the single tree. You can draw multiple such kind of trees. Multiple. This is again a same example. 4 leaf nodes, 1, 2, 3, 4, and still you have 3 nodes with 2 children. You can draw multiple such options. Multiple such options you can draw, and still you will get answer 3. Okay, I will give you another option. Don't worry. अरे रुको तो सही. अरे सर रुके तो सही. अरे आप solve करें तो सही. 1, 2, 3, 4. Yes. How many nodes are having 2 children? This one, and this one. This is not having, okay, sorry, not this one, this one. So this is not having 2 children. Fine. But 1, 2, 3. Still my answer is 3. 4 leaf nodes, 3 number of nodes with 2 children. Clear? Okay. Now, if I can draw this kind of example easily, but if the number is large, little large, a binary tree T has 29 number of leaf nodes, then how many number of nodes you will be having with 2 children? And in that particular case, for this question, you need to understand the concept. You need to understand a concept. You don't have to remember the formula. Okay, I don't want you to remember any kind of formula. I will never ever recommend it कि ये formula याद कर लेना as it is. I will explain you कि why that formula is. Why that formula is. So a binary tree having 29 leaf nodes, answer will be 28 as number of nodes with 2 children. And how it happens, I will tell you, I will solve it mathematically. I will explain कि ऐसा क्यों होता है. Mathematically, I will explain कि why it happens. 28 is correct answer, but why it happened that. Look at this. There is a handshaking lemma. There is a handshaking lemma. Okay. So initially I am taking I2. I2 means internal node with 2 children. Okay, so here my assumption is, assume I2 is internal node with 2 children. And capital L I am assuming as leaf nodes, number of leaf nodes, right? Let's start with the base case. Let us start with the base case when we have single node. Look at this. We have single node. Okay, we have single node. है ना? Now, look at this. If we have single node, do we have any child of this node? Do we have any child of this node? No, sir. If you don't have any child of this particular node, then can I say internal node with single child, internal node with 2 children is 0? Internal node with 2 children is 0. Can I say that? Yes. And how many leaf node we have in this particular tree? 1. Is this a leaf node? Yes, sir, it's a leaf node. Why? Just because it is not having any children. This is my base case. This is my starting base case. Single node I have taken. This particular node is not having any children. Yes, means it's a leaf node. Yes. So initially leaf node count is 1. And right now I don't have any node, internal node with 2 children. Fine. Let's go for the next case. I am increasing node with 2 children. I am increasing internal node with 2 children by 1 count. So what exactly I did? This leaf node I have converted into internal node. This leaf node I have converted into internal node. Okay, so how many internal node we have with 2 children? 1. One internal node I have with 2 children. Fine. Now look at this. Very easy, very straightforward understanding. This node previously was leaf node. I have converted it into internal node, right? So if I have converted a leaf node into internal node, I have decreased the leaf node count by 1. From this tree to this tree, if I am going, I have decreased initially the leaf node count by 1. Why? Just because previously this was a leaf node, इसको अब leaf node से हमने internal node बना दिया. So when this was counted as leaf node, next time you will not count this as leaf node. So by how much? 1. By 1 you have decreased the number of leaf nodes. Fine. But after adding 2 children, you have increased the leaf node by 2. You have increased the leaf node by 2. So you have taken 1 leaf node count and you have given 2 leaf node count. Subtract 1, add 2, effectively how much increase? Effectively how much increase? कितना बढ़ गया? कितना बढ़ गया? Answer is 1 से बढ़ गया. Previously if 1 leaf node you have, then 1 more increased. Now it is 2. नहीं समझ में आया? Did you get it or not? What I told कि if you are increasing an internal node with 2 children, then previously we had 1 leaf node. This was a leaf node. Yes, we have converted this node into internal node. So leaf node count decreased by 1 and we have added 2 leaf nodes. So increased by 2. Minus 1 plus 2 effectively increment by 1 means previously if we had 1 leaf node, now we will be having 2 leaf nodes. Now if you will go for the next option means let's increase the internal node by 1 more. So previously this example you had this one or this one, any of the leaf node you can choose, you can select and convert this into internal node with 2 children. Okay, I have increased this particular node, or I have converted this leaf node as internal node with two children. Now how many internal node with two children? 1 and 2. So if you have two internal node with two children, 1 2 3 leaf node you are having. From previous case, one more. From previous case, one more. If you increase another internal node with two children, whichever you want, this one or this one, suppose I am increasing this one, how many internal node with two children? 1 2 3. Because of that, you are having number of leaf nodes is equal to 4. And if you are increasing even number of internal node with two children, one more, koi bhi increase kar do, here, wherever you want you can increase. If number of internal node with two children is 4, then you will be having leaf nodes 5. So from this base case, if you are increasing x number of I2. X number of I2 means x number of internal node with two children. You will be having total x plus 1 leaf nodes. X plus 1 leaf nodes. Why? Base case you had 1 leaf node, and for every x you will be having 1 leaf node increased. For every x you will be having, what? You will be having this particular increment. 1 leaf node increased because of each internal node of two children. अंडरस्टैंडिंग? अभी आपके पास डाउट नहीं होगा, हो सकता है यू डोंट हैव डाउट. आई विल पुट द डाउट इन योर माइंड. मैं डालूंगा और उसके बाद उसको सॉल्व भी करूंगा. डाउट इज, सर इफ वन नोड विल हैव सिंगल चाइल्ड ओनली, तो उसका क्या फर्क पड़ेगा? What will be the effects? What will be the impacts of having nodes with single child? Okay, I will give you the example. Don't worry. Look at this tree. Look at this particular tree. This is the tree, right? How many internal node with two children? 1, 2, 3, and 4. 4 internal node with two children, 5 leaf nodes. 1, 2, 3, and 4, and 5. 5 leaf nodes. My understanding is still clear. Ki if I have increased from the base case, if I have increased internal node with two children equals to 4, 1 plus 4 is equal to 5 leaf nodes will be there. Now if I am increasing single child node, this leaf node I have converted into internal node with single child. Now listen, previous node, yes sir. I have converted it into internal node, yes sir. Means previously leaf nodes count decreased by 1, and how many children we have added for this one? Only 1. Means decreased by 1, increased by 1. Number of leaf nodes not increasing. You can see 1 2 3 4 and 5. Number of leaf node बढ़ा ही नहीं. Number of leaf nodes will remain same if you will have 0 number of internal node with single child, or 1 number of internal node with single child, or 2 or 3 or 4 or 1000 number of internal node with single child. अगर एक चाइल्ड के कितने ही नोड आप रख लो, numbers will not increase. Number of leaf nodes will increase only when you will have internal node with two children. So you can have certain example like this. You can increase so many levels, so many number of internal nodes with single child. You will always have 5 number of leaf nodes in this example when we have 4 internal node with 2 children. करके देख लो आप, आपको यही प्रूफ मिलेगा. एंड इट्स वेरी सिंपल थिंग. इट इज वेरी सिंपल थिंग. समझ में आया क्या? Did you understand? Yes or no? So from here I am going to write a simple understanding for you, which is this, कि total number of leaf nodes will always be number of internal node with 2 children plus 1. Is that clear or not? Is that clear or not? Everybody, can you acknowledge so that I will be going forward? मैं फिर आगे बढ़ूंगा और आगे की चीजें आपको बताई जाएगी. जल्दी से बताओ, क्या इतना क्लियर है सब लोगों को? सो आगे बढ़ते हैं, आगे बढ़ते हैं। ठीक है, ठीक है। उसका आगे वाला क्वेश्चन सॉल्व करने के पहले आपको एक चीज में याद दिलाऊंगा। आई विल रिमाइंड यू वन थिंग। यस्टरडे आई टोल्ड यू n, which is total number of nodes, is equal to total leaf nodes plus total internal nodes. Did I tell you this? क्या मैंने आपको ऐसा कहा था? Yes, total number of in the tree. Crystal clear, क्या बात है। Total number of nodes in the tree, L is equal to total number of leaf nodes in the tree, and I is total number of internal nodes in the tree. Now, assuming we have binary tree. Assume for a binary tree, can you tell me a node can have how many children? A node can have 0 child, means it's a leaf node. Or a node can have 1 child, it's an internal node. A node can have 2 children, again it's an internal node. So for internal node, we have two options. For a binary tree, I1 is those internal nodes which are having single child. Internal with 1 child. And I2 is those internal nodes which are having 2 children. Can you tell me total number of internal nodes kitni hongi? Then I can write that total number of internal nodes. Some internal nodes are having 1 child, some are having 2 children. Total internal nodes will be number of internal nodes with 1 child plus number of internal nodes with 2 children. इज दैट क्लियर टू एवरीबॉडी? क्या ये क्लियर है सब लोगों को? क्या ये क्लियर है सब लोगों को? यस और नो, यस और नो, यस और नो। एंड वी हैव जस्ट proved that total number of leaf nodes are equal to number of internal node with 2 children plus 1. Is that clear? Just now we have proved here total number of leaf nodes are dependent on only those nodes which are having 2 children. 2 children internal nodes plus 1 is total leaf nodes. And here total number of leaf nodes I2 plus 1 I have written. Total internal nodes are I1 plus I2. So in that particular case, I can write capital N is equal to L, which is I2 plus 1 plus I, which is I1 plus I2. I can have a number of nodes ka different formula, which is 2 times number of internal node with 2 children plus I1 plus 1. Is that clear? Is that clear or not? If that is clear, then we should go forward. We should go forward and let's solve a question. Let us solve a question. Very simple question it is. In a binary tree, the number of internal nodes of degree. Yesterday I told you degree means child. Degree 1 is 9, means single child. Single child internal node is equal to 9. And the number of internal nodes of degree 2 is 18, means number of internal nodes with 2 children is equal to 18. Total number of nodes in a binary tree, how much? We will calculate everything. Total number of leaf nodes will be I2 plus 1, which is 18 plus 1, 19. Right? Total number of internal nodes will be I1 plus I2, which is 9 plus 18, 27. Right? Total number of nodes will be L plus I. In fact, you could have written directly 2i2 plus i1 plus 1. It will be 19 plus 27, which is nothing but 46. Or if you will be writing like this way, then it will be 2i2, 2 into 19 plus 9 plus 1, which is nothing but 46. So in both the way you can calculate. जैसे आपको करना है वैसे आप कर सकते हो. It was very simple now for you guys. Is it simple for you or not? Is it simple for you or not? Yes or no? Yes or no? Yes or no? Yes or no? If it is simple, if it is simple, if it is simple, if it is simple, then we will go for the next thing. Another thing. Minimum and maximum number of nodes in a binary tree on a level number L. So let's talk about minimum. How many minimum nodes you can have on a particular level? So let's draw a tree in which on each level we can have minimum nodes. Like this way you can have. Is this example? Yes, sir. So what is the answer for minimum? Answer for minimum is 1. On one particular level, minimum number of nodes possible is 1. So level number 0 is having one node. 1, 2, 3, 4. 0, 1, 2, 3, 4, 5. Can we say level 6 hai? Can we say level 6 is there or not? Can we say level 6 or not? Is there any level 6 present here? Okay, my bad here. It's not 19, it's 18. Okay, so for this 18 plus 19 plus 27 here is 80. Fine. Okay. Can we say we do have 0, 1, 2, 3, 4, 5. Sixth level is present or not? This is on the fifth level. Is there any sixth level present? No. So can we say minimum number of nodes at level number 6 is 0? Level 6 है ही नहीं तो नोड कहां से आएगा? So there is no any possibility of node 0. 0 नहीं हो सकता. Minimum 1. Maximum. Let's talk about maximum. Let's talk about maximum. Maximum कितना होगा? Maximum होगा for every level you fill all the entire possible nodes. All the possible nodes. Every child will have, or every node will have two children, and last level of course will not have any child. So in that particular case, this is level number 0, this is level number 1, this is level number 2, this is level number 3. So for level number L, what is the number of nodes maximum? Look at this. Let's have a particular table. On level number 0, I do have number of nodes 1. On level number 1, I have maximum nodes 2. On level number 2, I have number of nodes 4. On level number 3, I have 1, 2, 3, 4, 5, 6, 7, 8 number of nodes. So on the level number 3, 8 number of nodes are there. So if I want to write a simple formula in terms of L, n max ka n number of nodes are there, maximum with L level will be how much? 2 power L. 2 power L. 2 power of nodes will be there. If L is 0, 2 power 0 is 1. If L is 1, 2 power 1 is 2. If L is 2, 2 power 2 is 4. If L is 3, 2 power 3 is 8 number of maximum nodes you can have on that level. Is that clear or not? Oh yes. Exactly. Got it. Everybody got it. Yes or not? Yes or not? Yes or not? Yes or not? So if level number is L, if level number is given as capital L, number of maximum nodes on that level number L is 2 power L and minimum is 1 always. Whichever level it is. Okay, clear? Should we go next? Should we go next? Another question. Minimum and maximum number of nodes in a binary tree of height h. So you have a binary tree of height h, and you need to construct a binary tree which can have minimum nodes. Okay, so let's take a simple example. Let's take a simple example. Such kind of table only we will draw, and different trees we will draw, so that for each height we can write the answer. Okay, so here I am writing the height h and minimum with height h. First of all, height of a tree with single node is 0. So this is my base case. Single node, what is the height? Height is 0. How many number of nodes? 1. So height is 0. Number of nodes are 1. Now let's go and increase the height. We want minimum nodes, yes. So to increase the height, we will need another single node only. This is the minimum node tree. Yes, height becomes now 1. And how many number of nodes are there in this particular tree? 2. So when height becomes 1, number of nodes are 2. Fine. Now I cannot conclude everything. If such kind of examples you are constructing, and if you are giving such kind of table, based on the table you will want to give the formula, please, it's a recommendation that minimum 4 examples you need to take. कम से कम 4 example लेने का minimum 4 examples you need to take. So I am taking another example. Let's increase the height. To increase the height, I can increase one more level, single node required. Now height is what? Height is 2 and number of nodes become 3. So case 2 height, number of nodes 3. Another example, suppose let's increase the height by one more. If we are one more, whichever side you want, left or right, height becomes 3, number of nodes 4. So when we are increasing height by 1, the number of nodes becomes 4. Now in this case, you can write the formula. N number of nodes which are minimum with height is equal to how much? How much it is? It is h plus 1. 1 more than h. When h is 0, it is plus 1. H is 1, it is 2. H is 2, it is 3. H is 3, it is 4. Very simple it is. Good, good, good. Nice, amazing, amazing, amazing. Now we want to go for the same thing with maximum number of nodes. With maximum number of nodes, let's have same kind of example. So this is the height h and I want to calculate n max with height h. So initially, this is the base case. Single node, yes. Single node height is what? Single node height is 0, number of nodes equal to 1. So height is 0, number of nodes are 1. Let's go for another example. Let us go for another example. Another example is this. If we are increasing the height, we want maximum nodes, means next level I have to make full. Maximum possible nodes is this. So h height becomes 1, number of nodes become 3. So when height is 1, number of nodes are 3. Let's have another example. Abhi koi conclusion nahi. There is no any conclusion. So if we will increase another height, means you need to increase number of nodes so many. I need maximum nodes. Sare levels ko full kar diya. All the levels are full. Maximum nodes, yes. Height becomes, in this case, 2, 0, 1, 2. Height becomes 2 and number of nodes, how many count karenge? 3 plus 4, 7. So for height 2, number of nodes 7. And then another example. Let's have one more example. Let's increase the height for one more level. If you will increase the height by one more level, 1, 2, 3, 4, 5, 6, 7 and 8 more. 8 plus 7, 15 number of nodes you are having. So when height is equal to 3, number of nodes are 15. For height equals to 3, number of nodes 15. Of course, for height 4, you will be having number of nodes total 31. So this 31 is 2 power 5 minus 1. minus 1. This is 2 power 3 minus 1. This is 2 power 2 minus 1. This is 2 power 1 minus 1. And hence we can write a formula, and formula is, if I want to give maximum number of nodes with height h. If height is h, this is 2 power 4 minus 1. 15 is 2 power 4 minus 1. From 3, you need to make it like that way, 3 plus 1. 2 power h plus 1 minus 1. That will be the formula. And this kind of formula, please, you don't have to remember. You don't have to remember immediately, instantly. You can understand the concept and you can get the formula instantly. So it's like a Maggie instant making option for you in the exams. You don't have to remember as it is. Why? Just because sometimes it might possible that they may give the height definition something different. Single node के साथ height अगर 1 दे दिया तो in that case formula will change. So you need to be little bit flexible in your approaches ki how exactly you are going to solve such questions so that you can understand the topic easily. अभी मैं एक क्वेश्चन दूंगा. I will give you a question and that particular question you need to make for you live. Yes, I will wait for your answer. There is a binary tree with n number of total nodes. The root is only node in the tree having odd number of children. I need number of leaf nodes in tree are how many? How many number of leaf nodes we can have in the tree? How many leaf nodes in the tree will be having? So there is a binary tree with n nodes. Okay, root is only node in the tree having odd number of children. Odd number of children matlab 1. Let's say for example, given n is greater than 2, 2 से ज़्यादा nodes हैं आपके पास, means only root we have which is having how many single node. Odd number of children matlab 1 node na. Binary tree में odd number of children means 1. Even means either 0 or 2. So you are an example like this way. In the tree only root is having single child, remaining all the nodes are having 2 children, and leaf nodes are there. Okay, so you need to give me how many number of leaf nodes are there in the terms of n. Now you solve the question. Also solving the question, I can say that if n number of nodes are there and among those only root is having odd number of children, means it is having one child. I1 is equal to 1. Can I say that? Yes, of course. So total number of nodes we know 2 times I2 plus I1 plus 1. Right? And we know that 2 times I2 plus I1 is 1 plus 1, which is n is equal to 2 times I2 plus 2. I2 plus 2. Now we have the total number of leaf nodes. Yes, total number of leaf nodes are equal to total number of I2 plus 1. So can we get value of I2 from here in terms of L? Yes, L minus 1. Can you put value of I2 here? Yes. So it becomes n is equal to 2 times L minus 1 plus 2, and it becomes n is equal to 2L minus 2 plus 2. From here you will get the value of L is equal to n by 2. This is given in the question that n number of nodes are greater than 2. Got it? So you need to put all the learnings. You need to put all the learnings you have in your so that you can solve such questions. And that is why we always urge you to go for Unacademy Plus subscription. So many questions my students solve over there. They are going to solve such kind of so many questions. They have solved. Yesterday also they had some kind of questions in their test and they were successfully able to solve such questions in the test also. So when we say कि we provide something which is very different, very peculiar in the Unacademy Plus, such kind of so many questions so that you can actually learn how you are going to employ your understanding, your knowledge in problem solving so that in the exam you will be very, very quick. If I will be giving you 1 hour extra or 2 hour extra in the gate exam, suppose your gate exam is just 3 hours, if I'll give you 6 hours, definitely you will score 6 or 7 or 10 marks more. But just because the time limitation, if you know quickly that how to solve a question quick, then in that you will be able to solve the questions quickly and you will be able to score. Otherwise you will stuck in one question for more than required time and hence you know the things but still you are not able to crack the gate with maximum marks. So you need to somehow be that ready so that you can solve each and every question with quickly with less time, and hence such kind of classes definitely help you in the same regards. So when we come on Unacademy Plus, we actually mean for it कि we what we provide there which is different one. आज बाइनरी ट्री ट्रैवर्सल होगा, इशू आज ट्रैवर्सल नहीं हो पाएगा, ट्रैवर्सल हम करेंगे कल. ठीक है? ओके, अनदर क्वेश्चन, हाउ मेनी बाइनरी ट्री can be constructed using 3 unlabeled nodes. Unlabeled means there is no any key over there. There is no any key over there, right? So let's try to draw. So if I want to with 3 nodes, one kind of tree you can have this one, then one kind of tree you can have this one, then one kind of tree you can have this one, then one other tree you can have this one, and other tree you can have this one. Total 5 number of nodes you can have, or sorry, 5 number of trees you can have using a 3 unlabeled nodes. This is answer, but this is very given 4 unlabeled nodes, then how you will give the answer? Of course, it becomes difficult for you just because drawing trees, maximum, see, maximum permutations of 4 is 24. So maximum possibility is 24. Of course, you will not get 24. But itne sare tree banana, to draw those many trees will be difficult for you. What is the option here? It's not 3 factorial. It's not 3 factorial, it's less. There is a formula which is called as Catalan number. So in general, if asked that for n unlabeled nodes, how many binary trees are possible? So number of binary trees possible is equal to Catalan number formula, which is this 2n cn divided plus 1. This is a very specific formula which directly to our computer science view of the problems. There is a scientist in MIT, I am forgetting his name. He has collected some 200 problems on his website, and those all 200 problems are solved using this Catalan number. Yes, it's a Catalan number. Okay, remember that it's a Catalan number and it is a formula we are having here. That particular formula is this 2ncn divided by n plus 1. That's a combination. Okay, if you put the value of 3 here, as n value is equal to 3, 6, see 3 divided by n plus 1, you will get the same answer 5. So if you'll be going for n equals to 4, you'll be getting 14, then n equals to 5, you'll be getting, I guess, 42 and 132 and something. Now another question. This question says, how many binary trees can be constructed using 3 distinct keys? You have 3 keys now. Keys, values. Let's assume the 3 keys are A, B and C. Now using these, you need to construct the binary tree. How many binary trees you can construct? How many binary trees you can construct? So, number of binary trees you can construct using the 3 distinct keys. I will explain you how you are solving this. First of all, how many number of trees you can construct? Number of trees with unlabeled nodes. Unlabeled nodes. No any labeling, no any keys you are keeping. How many number of trees you can construct is 5. What are those 5s? 1, 2, 3, 4 and 5. Now let's choose this structure of a tree. This particular tree I have taken. Single tree. One tree, and in that particular tree I am going to populate the keys. Population of keys means I am going to put these ABC in this particular tree. One tree I have taken, populate the keys in this particular tree. So how can I populate these ABC key in the tree? Okay, let's try out. If I keep A as root, left side I can keep B, right side I can keep C. Or in fact I can make reverse also, left side B, right side C. Similarly, if I will be going for root as B, left side I can have A, right side I can have C. Or in fact root is B, left side C, right side A. If I take root as C, left A, right B, root C, left B, right A, how many possibilities of populating the keys? How many such possibilities of populating the keys, which is 6, which is nothing but 3 factorial ways. There are 3 factorial ways in which you can keep these 3 keys in a single structure. एक स्ट्रक्चर के अंदर in a single structure. Now let's take this tree. In this tree also you will have how many? 6 possibilities. In this tree also 6, in this tree also 6, in this tree also 6. So total possibility will be what? My answer for this question is 5 into 6, 30. Good, nice, amazing. Total 30 ways are there, or 30 distinct trees you can construct using 3 distinct keys. One design or one particular tree is this. In this tree you have 6 different ways so that ABC you can populate. Similarly, in this particular tree you have 6 such kind of 3 factorial ways. In this tree also, this tree also, this tree also. If the same question is asked in general way, then in general way, for n distinct keys. Tell me, for n distinct keys, how many number of binary trees are possible? Number of binary trees is equal to how many? Yes, first of all you will be having different types of tree using the Catalan number. These many number of trees are possible. In each tree you can populate the keys using n factorial way. So this will be your number of binary trees, regular binary trees with n distinct keys. Superb, amazing. Everybody is clear about this? क्या इतना clear है? Yes or no? Please tell me so that we can go further. Further is what? Tomorrow I am going to talk about tree traversal, and tomorrow is going to be the most important topic. Yes, this is most important topic of your binary tree. If you understand tree traversal, then everything will be very easy for you. Everything will be very easy for you. I will tell you how you traverse, and I will tell you how you traverse with my method, which is very different, so that you can get the traversal result in within just game. So we will be playing some games. Through those games you are going to calculate, we are going to learn the tree traversal. So don't miss tomorrow's lecture. Tomorrow's lecture you don't have to miss. Question is, sir, data structure lecture are enough hai? Sir, these lectures, if you are going to learn from first to last, and if you are able to solve maximum number of questions of your gate previous year, yes, of course, enough hai. Of course, in terms of study, what I provide is more than sufficient for my courses, whether it is computer organization. If you go and check out a playlist already there, COA 52 lectures are there. That particular playlist, look at this, such kind of playlist, you can check it out in the same channel. This thumbnail is there. That playlist 52 lecture, more than sufficient for your gate syllabus. And this is my entire team working in and out so much hard for you guys, so that you can learn a lot. So this is, of course, this is very good initiative we have brought for you. You need to just come live daily and interact with us, so that you can have effective learning. If you want the other courses, COA ka crash course is going on. This particular COA is complete series. If you want complete series from scratch, watch these 52 lectures. And if you want a crash course, you just check out crash course, which is different playlist. And there are some new courses which are coming. So instead of this C language, it will be completed within 1 day or 2 day, and another course is coming in place of this, another course from next place, and another course from next week coming from in place of COA also. 3 p.m. already mathematics is going on. You can check it out. One more thing, how to revise the topics. For that, 12 p.m. I am going to have a very special session on Unacademy special. So you come on Unacademy special class, and on Unacademy special class we are going to have this particular session. Apart from that, tomorrow 9 to 11:30 a.m. tomorrow is Saturday, so I'm going to have a marathon session tomorrow 9 to 11:30 a.m. on YouTube. I am going to solve 60 MSQ questions. How many? 60 MSQ questions only on COA. I had personally all these questions in my free time. 60 questions MSQ type only you are going to solve here, and those questions we are going to cover in next 2.5 hours YouTube tomorrow 9 to 11:30 a.m. Saturday special class. Okay, so don't miss these classes. These are very important. Apart from that, if you want the PDF of all these lectures, you can join this Unacademy Gate CS channel of the Telegram. This is the channel where we drop all the PDF of the class. And then this is the way so that you can be connected with us on Facebook. Gate aspirants pages for ECIN electrical, this one, for MECS, this one. Be connected with us. These are the channels our family is providing you guys. Why I am having my hand here? Just because we, as proud member of Unacademy's team, are providing you lot in terms of quality education. This is the channel Unacademy Computer Science, where we come and teach you live day-to-day basis, and so much we are teaching you in so effective way. It's your chance now to pay back us in terms of your support. How you can give us support? You just share the links of these lectures with all of your friends, so that they also can come live, or they can watch the recorded videos, so that they can learn in more effective manner. Apart from that, this is the channel for electrical members. If you have friends in electrical, you can let them know mechanical, civil, Telugu language चैनल अलग से वी हैव, देन एसएससी जेई चैनल, आरआरबी एंड एसएससी के लिए जीएस टर्मिनल फॉर जनरल स्टडी कोर्सेस. So these are the channels we are having. Let them know we are teaching you in a good quality and let them also learn. Okay, thank you so much for joining here. My favorite quote, happy learning, keep learning. This lecture, please like if you haven't liked, and share the playlist and lectures, subscribe the channel, and ये घंटी बजा देना यार. Keep your notifications on, so whenever I'll be coming for the classes, you will be getting the notification after that. Thank you so much for joining here. We will meet soon. Till then, have a nice day.